Welcome to Math, where problems are no problem. How do we measure how spread out a set of numbers really is? That's exactly what standard deviation tells us. And by the end of this video, you'll know how to calculate it by hand, step by step, using one simple data set. Before we dive in, let's get clear on two ideas. First, the mean, which is just the average of your numbers. Second, a deviation, which is how far a single number sits away from that mean. Standard deviation basically answers the question, on average, how far does each number stray from the center? Let's use one data set for the whole video. 2, 4, 4, 4, 5, 5, 7, 9. That's 8 numbers total. Step 1. Find the mean. We add up all the numbers. 2 plus 4 plus 4 plus 4 plus 5 plus 5 plus 7 plus 9 equals 40. Then we divide by how many numbers we have, which is 8. 40 divided by 8 equals 5. So our mean is 5. Step 2. Find how far each number is from the mean. This is called the deviation, and we get it by subtracting the mean from each number. 2 minus 5 is negative 3. 4 minus 5 is negative 1. And we have 3 4s, so that's negative 1 3 times. 5 minus 5 is 0, and we have 2 5s, so 0 twice. 7 minus 5 is positive 2. 9 minus 5 is positive 4. Now here's the tricky part. If we just added up all those deviations, negative 3 plus negative 1 plus negative 1 plus negative 1 plus 0 plus 0 plus 2 plus 4, we'd get 0 every single time, because the negative and positive deviations cancel out. That tells us nothing about spread. So step 3, we square every deviation. Squaring does two useful things. It makes every value positive, and it punishes bigger deviations more heavily. Negative 3 squared is 9. Negative 1 squared is 1, and we have 3 of those, so 1, 1, 1. 0 squared is 0 twice, 2 squared is 4, 4 squared is 16. Step 4, we add up all those squared deviations. 9 plus 1 plus 1 plus 1 plus 0 plus 0 plus 4 plus 16. Let's add carefully. 9 plus 1 is 10, plus 1 is 11, plus 1 is 12, plus 0 is 12, plus 0 is 12, plus 4 is 16, plus 16 is 32. So the total is 32. Step 5. We divide that sum by how many numbers we have, which is 8. 32 divided by 8 equals 4. This result, 4, is called the variance. It's the average of the squared deviations. But variance is in squared units, which is awkward to interpret. If our original numbers were, say, test scores, variance would be in points squared, which doesn't mean much intuitively. So step 6, the final step, we take the square root of the variance to bring it back to the original units. The square root of 4 is 2. That's our standard deviation, 2. So what does that number 2 actually tell us? It means that typically each data point sits about 2 units away from the mean of 5. Let's verify this makes sense by glancing back at our original numbers. 2, 4, 4, 4, 5, 5, 7, 9. Most of them, 4, 4, 4, 5, 5, do sit close to the mean, within about 1 unit. The 2 at negative 3 away, and the 9 at positive 4 away, are the outliers pulling the average distance up a bit. A standard deviation of 2, right in between those extremes, feels exactly right. And if you want a quick sanity check on the math itself, variance times. Variance is not what we want, but standard deviation squared should always bring you back to variance. 2 squared is 4, matching the variance we calculated in step 5. That confirms our arithmetic held together the whole way through. So here's the one big idea to remember. Standard deviation is just the average distance each number sits from the mean after squaring to avoid cancellation and rooting to return to normal units. If this helped, the next video covers variance and how it's used in more advanced statistics. And if you've been finding these videos useful, subscribing helps them reach more people who are searching for the same thing.